Hey guys, what's up? It's been a little while since I uploaded my video the last time. Anyways, today we're going to talk something about lens, human eye lens. So let me write the topic here. Lens. So before going into the structure of the human eye lens, let me discuss some applied anatomy of the lens. I hope you're seeing the thing I'm writing here. Okay, cool. So lens. So under the applied anatomy, what we need to know is this pen is so reluctant to write. Maybe this is new pen, that's why. Yes. Under applied anatomy, you need to know is what is the shape of the lens. Under shape of the lens, you just need to know it is biconvex and crystalline structure. Okay, and where it is located actually. And its location is located between the iris and the vitreous. Okay, if you want me to draw the picture, then if this is your iris, and this is your vitreous humor. Okay, this is your vitreous humor and this is the lens. Okay, here should be much more curvature of the lens than the anterior curvature. Okay, anyways, now let's talk about the diameter of the lens. What is the diameter of the lens? Diameter usually varies from 9 to 10 millimeter, and it also varies with different books, but the book I'm referring says around 9 to 10 millimeter. And the surfaces, as I told already, the surface of the lens is much more curved posteriorly than the anterior surface. Okay, so it happens to be the anterior radius of curvature of the lens is a little bit more than the posterior one, because anterior is less curved, right? That means the radius of curvature must be greater, and the posterior is a little bit more curved, so the radius of curvature of the posterior surface must be a little bit lesser, right? So the book says the posterior radius of curvature is around 6 millimeter and the anterior radius of curvature is around 10 millimeter. Okay, and the refractive index of the lens is around 1.39. Okay, and yes, the depression just I talked about, this depression where the lens is opposed over the vitreous humor, this depression is called this is called, what is this called? This is called, yes, patellar fossa. Okay, and the next thing you need to know is what is the total dioptric power of the lens. Total dioptric power of the lens, it is around 18 diopter, right? But the range varies from 16 to 20 diopter. Okay, so the next one is accommodative power. The accommodative power varies with the age. For the people about 50 years of age, 50 years above, 50 years plus people have accommodative power of around 1 to 2 diopter, and for the people of 25 years of age who are adults, and they have around 7 to 8 diopters, and for the babies who are from birth to 14 to 60 years of age, it is around 14 to 16. Okay, I think this is not up to the puberty, because at puberty, during the puberty, the accommodative power becomes a little bit less and than it was during the birth. So let's consider this to be the accommodative power at birth only. Okay, I hope you understood me. So simply, just you need to understand it. The accommodative power at birth is around 14 to 16. Just you multiply this lowest value by 2 and this highest value by 2, and it comes the accommodative power at birth. Okay, now I think I've discussed the things that we need in the applied anatomy of the lens. Now, yes, if anything is left, if I find later in this lecture, I will tell that. Okay, now let's get into the structure of the lens. Structure of the lens. I hope you guys are seeing this. Okay, yes, you are seeing. Now, structure of lens. Lens actually consists of 3 parts. Okay, lens can be studied into 3 parts. Lens. The first one is lens capsule. Lens capsule, right? And the second one is anterior epithelium. Anterior epithelium. And comes, you might be guessing posterior epithelium, right? But no, there is no any posterior epithelium. Why? I will tell you later. But the third one is lens capsule, anterior epithelium, and the third one is lens fibers. Okay, so now let's get into the lens capsule without any ado. So what is lens capsule? Lens capsule is nothing but it just hyaline membrane. Okay, it is transparent hyaline membrane. Okay, and it is thicker over the anterior surface. It is thicker, you should remember this. Okay, it is thicker at the anterior surface, and it is thinner. Yes, if it is thicker in the anterior surface, it literally means it is thinner at the posterior surface, right? But one important question they may ask you in a bio or even MCQs is that the lens capsule is the thickest at the pre-equator region. So you should imprint this in mind. At pre-equator region, lens capsule becomes the thickest. Now, come on. Now, thickest means how much? What is the range? It's around 14 micron. The highest possible thickness is 14 micron, and the least possible thickness is around 3 micron. Okay, that's 3 micron can be in the posterior pole, and this 14 micron, the thickest one, can be at the pre-equator region. Okay, now let's get into the anterior epithelium. Okay, anterior epithelium. And under this, anterior epithelium, what we need to know is it just lies below the lens capsule. Okay, suppose this is your lens, and let me use another black pen, and this is your lens capsule. Okay, and if this is your lens capsule, it lies around here below this lens capsule. Okay, so this anterior epithelium is the single layer of epithelium. Okay, anterior epithelium. Let me write the subtopic here, anterior epithelium. Okay, rather I will turn the page so it'll be easy for you to visualize, and I need to see the alignment on the paper, whether it is seen clearly or not. And here I like to apologize because and today, since I'm using new pen, it is a little bit not clear. Anyways, hope you will cope up with that. Now, yes, anterior epithelium, right? Anterior epithelium. And the anterior epithelium, is the single layer of epithelium. Single layer of epithelium, and it is cuboidal epithelium. But at the equatorial region it changes to columnar. Okay, columnar epithelium at the equatorial region. And this columnar epithelium in the equatorial region divides actively. You should imprint this thing in mind, okay? The columnar epithelium at the, let me make another figure. Yes, suppose this is the lens capsule, and this is the cuboidal epithelium, right? But at the equatorial region, this becomes columnar, right? This becomes columnar, and this columnar epithelium in the equatorial region divides actively and elongates. See here, it is elongating. It will elongate even more. And they elongate to form the new lens fibers. And these lens fibers are formed throughout the life of a human being. So, there is no posterior epithelium. That's why it has only been said anterior epithelium, no any posterior epithelium. And these posterior epithelium are, utilized in filling the central cavity of the lens vesicle during its development. Right, so you should imprint this thing in your mind. Now let's get into the third structure, that is lens fiber. We discussed lens capsule, we discussed anterior epithelium, and now let's get into the lens fiber. Okay, so under lens fiber, only the thing you need to know is, I'll tell you here, subtopic number 3, lens fibers. This is number 2 and this is number 3. Under lens fibers, what you need to know is lens fiber is nothing but these are epithelial cells, which elongate later and forms lens fibers. Okay, epithelial cells elongate to form lens fibers, right? And another thing you need to know is mature lens fibers are cells, which have actually divided their, which have, lost their potentiality to, divide, or which have lost their nucleus. Okay, mature lens fibers are, are such type of cells, which do not have nucleus, or nuclei, nuclei, or simply you can say mature lens fiber cells are the cells which have lost their nucleus. And lens fibers are formed throughout their life, throughout the life of a human being. So they're arranged in 2 different layers. The middle portion, or the center portion of the lens, is so much compact that, in the slit lamp examination, we can see a kind of discontinuity. Suppose this is so much compact, this center, and this is not so much compact. So when you see in the slit lamp, you can see some area of discontinuity right here at the junction of the hardest part, that is nucleus, and compact part, that is nucleus, and the peripheral cortex part, right? I hope you understood what I meant to say. There is the nucleus and the cortex part of the lens, right? This nucleus is so much compact, and the peripheral, this cortex part, is not that much compact. So when you examine in the slit lamp, you can see area of discontinuity. Okay, discontinuity, and that is the junction between this nucleus, that is the compact part, and this cortex, that is less compact part, right? So I hope you got me. Now let's get into the nucleus part. Okay, this is nucleus and this is cortex. So what is there inside nucleus? There are a few things you need to know under nucleus, and that is, nucleus are of different subtypes. Yes, during birth, rather during the development in the embryonic phase, there is different nucleus, and during fetal period there is different nucleus, and during infantile period there is different nucleus, and during adulthood there is different nucleus. So the nucleus that is present during third month of life, 0 to 3rd month of life, or 0 to 3 month of gestational period, the lens is called, the nucleus is called embryonic nucleus, and the nucleus that is present from 3 to 3 months to birth, this is called fetal nucleus, and from birth to puberty, the lens is called infantile lens, because the compactness and the structure a little bit, and the structure of the lens fibers changes with the age of the fetus or with the age of the baby, and the lens fibers changes and becomes different in their structure and compactness. So that's why the lens after the puberty, the nucleus after the puberty is named as adult type of nucleus. Hope you got what I wanted to say. Now, this nucleus actually, this nucleus, this fetal nucleus lies around the embryonic nucleus. Okay, lies around the embryonic nucleus, and it corresponds to the lens from the 3 month of gestation till birth. Okay, and the anterior surface of the lens, has Y-shaped suture, and posterior surface of the lens also has Y-shaped suture. Do you get me? Suppose this is your lens, this is anterior surface, and suppose this is the posterior surface of your lens. So the Y is inverted. Both anterior and posterior surface has the Y-shaped suture, but one is inverted in respect to another, right? So and these sutures are the very place where the fibers meet with each other. You see, the fibers meet with each other. You see, these sutures are the very place where the fibers meet with each other. And yes, as I already told, infantile nucleus corresponds to the lens from birth to puberty, and adult nucleus corresponds to the fibers formed after puberty, okay, to the rest of the whole life. And as I told already, embryonic nucleus corresponds to the lens up to the first 3 months of gestation. And now let's get into the cortex. Yes, under lens fibers, we talked about this nucleus and now cortex. And cortex is nothing but it's just the peripheral part, of the lens. Okay, it's the peripheral part of the lens, and it comprises, the youngest lens fibers. Okay, just you need to know this much. It consists of the youngest lens fibers. That's all. So, and next topic remaining under this lens, we'll be talking in next lecture. For now, this much for this chapter. Thank you.